Hello, good morning, students. In the previous class, we had a discussion on the properties of nucleus. And I explained you the properties such as nuclear size, nuclear charge, nuclear mass, nuclear density, and lastly, before leaving the class, I explained you the property in brief, the nuclear spin. Just I need to explain you some few points regarding the nuclear spin, few more points, and then we'll go further. Nuclear force. What is the, even though you know the constituents of the nucleus, that is protons and neutrons. Neutrons are electrically neutral. Protons are electrically charged. They are like charges. They have same charge. That is, protons have a positive charge. So even though they are having positive charge, but they are existing together inside the nucleus. From electrostatics, you know, there is a force of repulsion between the like charges. Between the two protons, there must exist a force of repulsion. But even though, how do they exist together inside the nucleus? What makes them to be inside the nucleus? As you know, its size is very small. There must be some other force which has to hold these nucleons. So about this, and one more thing, what is the cause for this to origin this force? So about these things I explain you today. First of all, let me explain you some few more points regarding the nuclear spin. As I told you, so the spin of the nucleus is because of the spin of the nucleons inside the nucleus. You know nucleons. Nucleons are nothing but the protons and neutrons together. Suppose, imagine this is a nucleus. Imagine this is a nucleus. Inside the nucleus, we have a nucleons. Say these are the nucleons. And distribution of these nucleons is not uniform. So here imagine that we have a nucleus whose atomic number is 5. Say these are the R3, let it be 3. Say it is a lithium nucleus. If I say it is a lithium whose atomic number is 3, so I assume this is one of the isotope of lithium, because it has 3 protons and 2 neutrons. Let us assume that. Say it may be lithium or it may be helium. That doesn't matter yet. For example, say this is a proton, this is a proton, and this is a proton. These are the 2 neutrons inside the nucleus. This entire nucleus is spinning about an axis with some angular velocity, and it has some angular momentum. So usually angular momentum we denote it by the letter L, small l, or it may be a capital L. But when we take it in a whole, in combination, we denote it by the letter capital L. For a single particle, we generally represent it by the letter small l. Okay. If at all, what is this? This is the net angular momentum of net or total angular momentum of the nucleus. This is the total angular momentum of the nucleus. So you know the meaning of angular momentum. It is nothing but a measure of rotational inertia of a body. How much a body is, how much a particle is having a rotational. What is a rotational motion contained in a body? The measure of rotational motion contained in a body we call it as angular momentum. So here, this entire nucleus is spinning about an axis. This is the axis. This is the axis. But what makes this nucleus to spin about an axis? So here, the combined, the sum of the angular momentum of all the nucleons inside the nucleus make the nucleus to spin about an axis. So here the protons inside the nucleus, this is also spinning. This proton is also spinning. This neutron is also spinning. So here these nucleons, among the nucleons, few nucleons will have the clockwise spin and few nucleons will have the anti-clockwise spin. So few nucleons. So first of all, let us spin of the nucleus is because of the spin of the nucleons. Spin of the nucleus is because of the spin of the nucleons. Some nucleons here, some nucleons have clockwise spin, and some nucleons have anti-clockwise spin. Here, that means the nucleons which are having that is a clockwise spin. Some nucleons which have some clockwise spin and some nucleons have anti-clockwise spin. So here the nucleons which are having the same type of spins, that is clockwise, there we can call them as that is a parallel spin. And those nucleons which are having the anti-clockwise with that is clockwise, they are called as that is a anti-parallel spin. In case of clockwise spin, there is a more force of attraction, whereas in case of anti-parallel spin, there is a less force of attraction. So here the spin of the nucleus is because of the spin of the nucleons. The spin of the nucleus is because of the spin of the nucleons. So here we can take this is that is some nucleons have a clockwise spin, some nucleons have anti-clockwise spin. So this is what about the spin of the nucleus. So what is why do nucleus has a spin? So the spin of the nucleus is because of the spin of the nucleons inside the nucleus. Okay, now let us know about the nuclear force. Let us know about nuclear force. What is a nuclear force? You know the meaning of force? What do you mean by force? Of course, in first year you learn about force. It is an external agent which produces either push or pull in a, either it may be a microscopic particles or it may be a macroscopic matter. That's particles. Sorry, matter. Now, what do you mean by nuclear force? So far I have explained about the nucleus. You know the meaning of nucleus according to as explained by therefore it is a positively charged central core of an atom. The entire mass of atom is supposed to concentrate at its center. That we call it as a nucleus. Okay. You know the constituents of the nucleus. Constituents of the nucleus. Constituents of the nucleus. That is, what are the constituents of the nucleus? That is protons and neutrons. Protons and neutrons. So, as you know, protons are positively charged and these are neutral. From electrostatics, you know, a force of repulsion between the like charges. There is a force of repulsion. Force of repulsion. We can observe the force of repulsion between the like charges, that is the protons inside the nucleus. There is a force of repulsion between the protons, but even though they are existing together in a very small region, very small space. How? So, to know about this, first of all, we should know the origin of the nuclear force. We should know the origin of the nuclear force. How these nuclear forces originate? To understand it better, let me explain you the things happens in our daily life. For example, the day when you enter into the college, you might have observed, we will have a friendship. How do we have a friendship? Friendship means the kind of force of attraction. When do we will have a friendship with our neighbor? So until and unless you exchange some things with your neighbor, you cannot find a force of attraction. You cannot find a force of attraction. This is the thing we observe around us. The same thing happens inside the nucleus. The same thing happens inside the nucleus. How? If at all there is a force of attraction among the nucleons, if at all there exists a force of attraction among the nucleons, there must be exchange of something. So here, let us know about the origin of the nuclear force. Origin of the nuclear forces. So here the question Even though that is protons exist inside the nucleus as they are positively charged, but there must exist some repulsive force. Even though because of even this repulsive force, that is of nucleons, that is protons are held together inside the nucleus. How this question successfully explained by a Japanese scientist in the year 1935. In the year 1935, a Japanese scientist by the name Yukawa, a Japanese scientist by the name Yukawa, he explained, first of all, he assumed it. He suggested there must some exchange of some matter inside the nucleus among the nucleons, which is responsible for the force of attraction among the nucleus. Of course, later on, experimentally discovered, proved, if at all something is exchanging among the nucleons inside the nucleus, what is that exchanges? What is that matter? So, a Japanese scientist by the name Yukawa explained, inside the nucleus, nuclear forces arises because of the exchange of particles called as mesons. He called them as pi mesons. So far I explained what? The constituents of the nucleus is only, that is, are protons and neutrons. But now I am explaining not only protons and neutrons are there inside the nucleus, we have some other particles also. That is one more particle, about one more particle I am explaining you. That is pi meson. So that means nucleus is not composed of only protons and neutrons. Now I am introducing one more particle, that is called as pi meson. So the nuclear force inside the nucleus arises because of the exchange of these particles known as pi meson. Here, in the pi meson, we have three types: pi plus meson, pi minus meson, and pi neutral meson. In meson, we have three types. Of course, I said third particle. In third particle, that is pi meson, we have again three types: pi plus, pi minus, and pi neutral meson. Here, the magnitude of mass of, that means, as I said, this is a particle, means it has a mass. The mass of this pi plus meson, the magnitude of mass of pi plus meson is 273 times the rest mass of electron. Means here the mass of this pi meson lies between the mass of proton and the electron. That is mass of nucleons and the electron. So its mass lies between that of lies between the mass of nucleons, masses of nucleons. Here nucleons I including both protons and neutrons, nucleons and electrons. Means it is the mass of pi meson is greater than the mass of electron, and it is less than the mass of the nucleons. So here mass of these charged nucleons, both pi plus and pi minus, mass of both charged you can say mesons, as I am showing here, that is plus sign and negative sign. So here this plus sign, negative sign, that represents the pi plus and pi minus meson have some charge, whereas it is neutral. The mass of these charged mesons is about 273 times the rest mass of the electron, whereas mass of this pi minus, that is neutral meson is 264 times the rest mass of electron, rest mass of electron. So if at all these two mesons, pi plus and pi minus, as I am showing it by the sign, they are the charge, then what is the magnitude of charge of these pi mesons, that is charged meson, pi mesons. So here magnitude of charge of pi plus meson, charge of pi magnitude of charge of these pi plus and minus meson is equal to magnitude equal to magnitude of charge of electron, magnitude of charge of electron. So as just now I explained you what is the origin of the nuclear force. Origin of the nuclear force inside the nucleus, and nuclear forces arises because of the exchange of particles. As who suggested about this? Yukawa. He assumed there must exist some exchange of matter inside the nucleus, which is responsible for the origin of the nuclear force. So what are the particles? That is pi mesons. What is the time that required to exchange these particles? So here the time taken for, that means if at all exchanging, what do you mean by here exchange? So that is absorption and emission of these particles by the nucleons inside the nucleus. That means by the absorption and emission of these particles by the nucleons inside the nucleus, this nuclear force arises. So here inside the nucleus, a proton will convert into a neutron and neutron will convert into proton. Say a proton, say P is a proton here. A proton will convert into neutron. A proton will convert into a neutron. A neutron will convert into a proton. Let us first how a neutron will convert into proton. How a neutron will convert into a proton. Look at it. So assume that I denote neutron by letter say small n. This neutron will convert into proton. Say, how can you remember this equation? So you know neutron is electrically neutral, proton is positively charged. Proton is positively charged. What that comes out of the neutron so that we get a proton. That means when that matter, the matter which is coming out of the neutron, the matters which are coming outside the neutrons, one is proton, which is positive charge. That means there exists some negatively charged particle. So here pi minus Visa means when that is a neutron when it emits a pi minus meson, we get along with that we get a proton. That means a proton is converting into a neutron is converting into proton. Similarly in reverse, if a proton captures absorb a pi minus meson, it will convert into a neutron. It will convert into a what? A neutron. Similarly, if a neutron or say if a neutron or if let us take a proton instead of that, let us take a proton. As I explained you, if it absorbs this. Suppose if a proton converts into neutron, it has to absorb this. If a proton has to convert into, so vice versa I explained. If a proton so when a neutron convert into proton, if a neutron convert into proton, it emits pi minus meson. Same if it absorbs, it will convert into a neutron. Next, if a neutron absorbs pi plus meson, it converts into a proton. It converts into a proton. Or a proton will convert into neutron in reverse. In reverse, a proton will convert into a neutron. A proton will convert into neutron by the absorption of pi plus meson. If a proton absorbs pi neutral meson, it remains as a proton. If a neutron absorbs pi neutral meson, it remains neutron. So here I explained you the conversion of neutron to proton, proton to neutron, proton to proton, neutron to neutron. How long they exchange? What is the time they require to convert a proton into neutron, and a neutron into proton. So experimentally it is observed that time required for the conversion of is about 10 to the power minus 23 second. You think about this number. The time required is about 10 to the power minus 23 second. Very, very, very small. If you divide this 1 by 10 to the power 23, whatever the fraction of time we get, that is very, 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 very small. That means in 1 second, how many times inside the proton, inside the nucleus, a proton will convert into neutron and a neutron will convert into proton. Large number of time a proton will convert into neutron and a neutron will convert into proton. So fast the exchange of these pi mesons among the nucleus, among the nucleons, originates the nuclear force, causes the origin of the nuclear force. So this is what about the origin of the nuclear force. So who introduced the concept of origin of the nuclear force? So the concept of origin of nuclear force was given by the Japanese scientist by the name Yukawa in the year 1935. In the year 1935, so he explained, and later on experimentally it is proved the existence of this matter called pi meson. In pi meson we have three types of mesons: pi plus, pi that is minus, and pi neutral. The pi plus and pi minus meson have the mass. That means, of course, here mass of this pi mesons lies between the mass of the nucleons, that is proton and neutron, and the electron. So nucleons and the electrons. So mass of this charged meson is 273 times the mass of the rest mass of the. Here we must have to specify rest mass of the electron, and the mass of pi neutral meson is 264 times. That means it is a little bit less than these charged mesons. That is 263 times the rest mass of the electron. So here, as I told you, these pi mesons are charged mesons. If at all they are charged, what is the magnitude of their charge? Here, the magnitude of the charge of these pi mesons, that is charged pi mesons, is same as the magnitude of the charge of electron. You know the magnitude of charge of electron, it is 1.6 into 10 to the power minus 19 coulomb. So how a proton will convert into neutron and neutron will convert into proton? By the exchange of matter known as pi mesons. So here a neutron will convert into proton and a proton will convert into a neutron. So here I have shown you the by means of a reaction. By means of a reaction I have shown you. So how long? So that is, what is the time required for the proton to convert into a neutron and a neutron to convert into proton? So the magnitude of the time required is about 10 to the power minus 23 seconds. So in a very, very small time, so these exchange of particles takes place. Of course, and every day, the more we exchange the things in a short time, so there is a force of attraction between among the ourselves. So similarly here, in a very short span of time, so these that is nucleons exchanges these pi mesons. So this is the cause for the origin of the nuclear force. Now, this is what about the origin of the nuclear force. So now I explain you the properties relating to the nuclear force. The properties relating to the nuclear force. So I explained you about the nuclear force. Properties. Properties of nuclear forces. Properties of nuclear forces. So, of course, I told you protons and neutrons are the constituents of the nucleus. They have some mass. What is their mass? Of course, in the previous class, I gave you mass of protons and mass of a neutron. So mass of proton MP, that is in terms in the SI system 1.6726 into 10 to the power minus 27 kg, whereas mass of neutron is equal to 1.6748 into 10 to the power minus 27 kg. Mass, because they are matter. These particles, that is nucleons, have some mass, means there exists some gravitational force. When we compare the gravitational force, strength of gravitational force with the strength of the nuclear force, and these nucleons are lying in a very small region. In the previous class, I explained you about the size of the nucleus. It is in Fermi. It is of the order of 10 to the power around minus 15 meter. In a very small region. Among the nucleons, proton, there exists a repulsive force. But even though they are existing together, so here, even though these nucleons have mass, of course, there is a gravitational force between the masses. When we compare the strength of the gravitational force with the strength of the nuclear force, it is very large. It is of the order of 10 to the power 38 times the gravitational. So hence, with this, what we can conclude, even though these nucleons have some masses, but nuclear force, that force between the nucleons inside of the nucleus, is not the gravitational force. The gravitational force alone is not sufficient to hold these nucleons together inside the nucleus. So hence, here first property is nuclear force is not a gravitational force. It is, nuclear force is not a gravitational force. Nuclear force is not a gravitational force. Nuclear force is not a gravitational force. Because when we compare the strength when we compare strength of nuclear force is 10 to the power around, that is around 38, or in some on an average we can say 39 times. Strength of nuclear force is 10 to the power 39 times the strength of gravitational force. Gravitational force. When we compare the strength of the nuclear force with the gravitational force, so here nuclear force is 10 to the power around, in some textbook by changing the decimal places, so here we can say 10 to the power 38 or even 10 to the power 39. So when we compare the strength point of view, so here the nuclear forces are not a gravitational force. Nuclear forces are not gravitational forces. Second point. Nuclear forces are not electrical forces. What it means? In electrostatics, you studied a force of repulsion between the like charges. Inside the nucleus, we find proton and neutron. You may think that, sorry, just now you said there exist some other particles whose charge is same as that of that is 5 mesons. Not only here we have 5 meson, we have some other types of meson, K meson, mu meson, like that. Presently we know more than 200 elementary particles existing inside the nucleus. The major role played by the origin of the nuclear force is these nucleons, that is exchange of 5 mesons. But even though they are existing, so here nuclear forces are not electrical forces. Between the protons there is a repulsion. There is a repulsive force. Even though there is a repulsive force, that is, these are inside the nucleus. So here the nature of this nuclear force is attractive. So here let us consider the second point as a attractive in nature. Nuclear forces are attractive in nature. It is attractive in nature only to certain separation between the nucleons. That means it is attractive up to the separation between the nucleons from 10 to the 0.5 into 10 to the power minus 15 meter, that is 0.5 Fermi to around 1.5 Fermi. Means if the separation between the nucleons is less than 0.5 Fermi, instead of attraction, the nucleons start repelling. Why do they repel? Because of their potential energy. So about this, in the first year, you learn this potential energy graph. The potential energy versus the distance or separation between the particles. So to a certain distance, say R0, here R0 is the limit of separation for the generating force of repulsion. Here it is a 0.5. So as the separation, if it separation between the nucleons, if it decreases less than 0.5 for me, so potential energy among that is a nucleons increases. Either it may be a proton or it may be a neutron. As their potential energy increases, force decreases. Force decreases. So because we have a relation force is equal to du by dr. So here negative sign indicates. So as that is a du by dr value increases, force decreases, like that we have. So here the nuclear forces are attractive in nature if the separation between the nucleons is in this range. Less than, greater than this. Less than this, there is a force of repulsion. Between this range, there is a force of attraction. So nuclear forces are attractive in nature. Third, they are not electrical forces. They are not electrical forces. They are not electrical forces. The nature of electrical forces is repulsive, whereas nuclear force is attractive. Between the like charges, there is a force of repulsion. Protons are existing inside the nucleus. Even though they are partially charged, we find as a force of attraction. That is why they are not electrical in nature. Nuclear forces are not electrical in nature. Here I explained you nuclear force. That means with this number we can observe that we can understand that nuclear forces are short range force. Nuclear forces are short range force. The next property is fourth one. These forces, that is nuclear forces, are short range. They are short range. Why? Because we can observe these nuclear forces to a certain region only. These nuclear forces in the nucleons exist to certain region. We find repulsion if it is less than repulsion. We find repulsion in the nucleons, among the nucleons, if it is less than 0.5 Fermi. If it is greater than 1.5 Fermi, say that is around 2 Fermi, then what happens? The nuclear force falls to 1/3 compared to within the region. So here these nuclear forces are short range forces. First, nuclear forces are not gravitational force because strength of the nuclear force is 10 to the power 39 times the strength of the gravitational force. Nuclear forces are attractive in nature provided the separation. We have to keep it in mind, the separation between the nucleons. Nuclear forces are not electrical forces. Nuclear forces are not electrical forces. Here one thing you can, if I compare the nuclear force with the electrical force, if we compare the nuclear force with the electrical force, nuclear force is around 100 times the electrical force. Strength of nuclear force is Strength of nuclear force is around 100 times more than the strength of the electrical force. That means when we compare the strength of nuclear force with electrical force, it is 100 times. That means here we can have a comparison of strength of gravitational force. Strength of gravitational force with the strength of the electrical force with the strength of the nuclear force. The strength is found to be about that is say 30. As here I have shown, it is about 39 times. So here it is around 37, and here it is 39. So here when we compare the magnitude of strength of there is gravitational force among the nucleons, that is between the protons, electrical force between the protons, and gravitational, that is nuclear force between the protons. So the strength is the magnitude of strength is found to be this. So these are the four properties relating to the nuclear force. That it doesn't mean that only we have four properties. We have four more properties. So fifth property. You know, protons are positively charged. Neutrons are electrically neutral. Inside the nucleus, there is a force of attraction between proton-proton, between neutron-neutron, between proton-neutron. Neutron is electrically neutral, even though one neutron is attracting other one. But with this, what we can conclude? With this, we can conclude that the nuclear forces are charge independent. Nuclear forces among the nucleons does not depend on their charges, whether it is charged or not. Purely depends upon separation between the nucleons. So here nuclear forces are charge independent. Nuclear forces are charge independent. We call nuclear forces are charge independent because there is a force of attraction between proton-proton, proton-neutron, neutron-neutron. So here there is a force of attraction between the nucleons, whether it is charged, irrespective whether it is charged or not. So that is why we call nuclear forces are charge independent. Next, sixth point. Nuclear forces are non-central force. What do you mean by non-central? In the first year, you might have, just if you recall, in first year we explained you about central force. Say in the chapter gravitation, we have a gravitational force between the Earth and the Sun. Of course, it is not a contact force, but how do it act? Here, the gravitational force act along the line joining the two masses. Here, inside the nucleus, there is a inside the nucleus there is a gravitational force between the among the nucleons. But when we come to the nuclear force point of view, nuclear force is not a central force. Means it does not act along the line joining the two nucleons. Does not act along the line joining the two nucleons. So that is why, say if I say this is one nucleon, say proton and another proton, it may be proton and a neutron. This is the line joining the proton and the neutron. Here, this nuclear force does not act along the line joining the proton and neutrons. That is why we say it is a non-central force. It is a non-central force. These forces are non-central force because it does not act along the line joining the two nucleons. Next point. Few minutes back, I explained you origin of the nuclear forces. Why the nuclear forces arises? You know, because of the exchange of the particles called as pi mesons. As it was explained by first Euclid. The exchange of these mesons is responsible for the origin of the nuclear force. With this, we can have one property. What is that? Nuclear forces are exchange type. Nuclear forces are exchange type. So here, nuclear forces are exchange type. Exchange type forces. Because the nuclear forces are originating because of the exchange of the some particles known as pi mesons. Here. Nuclear forces exhibit the property called as saturation. What it means? It means these forces exhibit saturation property. These forces exhibit saturation properties. What it means? Generally, if we get saturated, we always prefer to interact with our nearest neighbor. Similarly, inside the nucleus, say this is the nucleus, inside the nucleus, so say think that these are the protons. These are the neutrons, or you can assume. If I assume this is a proton and this is a neutron, again this is a proton, this is a proton, this is a neutron. If I take a reference of anyone, say assume here we have a number of protons inside the nucleus. If I take a reference of this one, if I take a reference of a neutron, if I say reference of this neutron, this neutron can interact with its immediate neighbor particle. It will not interact with a particle which is away. So here, this neutron, either it may be a neutron or it may be a proton, it can interact with its immediate neighbor next, rather than interacting with the other, which are away from that. So that is why we call nuclear forces exhibit a property called saturation. So I explained you the properties relating to the nuclear forces. They are the attractive in nature, they are short range, they are they are not central forces, they are not gravitational, they are not electrical, they are charge independent, they are exchange type, and they exhibit the property called that is saturation. So this is regarding the nuclear forces, origin of the nuclear forces. So we'll continue in the next class. Thank you.
Ati itu yang itu tadi,